is Mr. Ryan going over the Math 5 Chapter 3 test, sections 3.1, 3.2, 3.3, taken October 29, 2018. Directions: show all your work in the space provided and box your answers for those that apply. And then a set of questions here, it's 1 point each. For questions 1 to 8, identify and circle each as linear, quadratic, exponential, or neither. This graph is not a quadratic because quadratics don't have these tails. This is actually a cosine graph, so it's not linear, it's not aligned. Exponential increases very quickly or decreases, but not in both, like this one. And the answer is it's a neither, but it looks too much like a quadratic, so I'm not going to count this problem. Question number 2. I have a table of values here. Notice on this side you have plus 1s. And over here, I noticed I'm adding 3, then I add 5, then I add 7, and then I add 9. Now, if this was the same number, this is the first common difference. If they were the common one, then it would be linear. So it's not linear. And then if I do a second time, so plus 2, and I do a plus 2, and this is our second common difference, so this one would be, the correct answer would be quadratic. Question number 3, although you see x to the first power and are thinking linear, the reason why it's not linear, if you actually multiply these out, x plus 5, x plus 1, you're going to get x squared. X times 5 is 5x, x, 5, so this becomes x squared plus 6x plus 5. Here, when your y is the first power and then you have x to the second power, the correct answer would be quadratic. Question number 4. Eloise is worried that her secret got out. On the first day, she and her best friend were the only two people who knew. So the first day, or the very beginning, they were the only two that knew, so 2. But now, 2 new people are finding out the secret every day. Every day is a key word, so every day. So you'll recognize that this is in our slope-intercept form, starting with 2 people who knew it, Eloise and her friend, and then 2 new people every day. So x represents the number of days, and this function can help you find out how many, doesn't matter how many days, your answer is linear. Question number 5, linear, exponential, quadratic, exponential, or neither. So if you distribute the 5 here, you're going to get y equals 5x minus 5 plus 4. Combine like terms here, y equals 5x minus 1. X is to the first power, y is to the first power, that would be linear. Another table of values here. Notice here that the values are, you have to be a little bit careful here. It skips, so this is a plus 1. And here, you skip, so it's like a plus 4. So here, it's plus 1, and then plus 1. So just be careful of that. So from here to here, I get plus 7. And from here to here, I get plus 9. And from here to here, I get plus 3. So I'm going to assume this one and this one would be plus 5. So that would be kind of like a... we don't know, so you could graph it. Let's graph it. Just make this my graph right there. And let's get some tick marks. Just a very, very quick graph. And so negative 5, 0, 1, 2, 3, 4, 5. Negative 4. Negative 3. 0, 5, so up here 1, 2, 3, 4, 5. It has 112, something way up there, and then 221. So it looks like my graph's doing something like this. So you can, if you kind of use your table of values, you can kind of see so I went to graph some more graph paper so you can kind of see this. And I did negative 5, 0, negative 4, negative 3, Okay, and then it jumps up here to 0, 5, and then 112, which is off, and then 221. Okay, and what I saw here is if you made this pink line, this is called the axis of symmetry. These points are symmetrical to these points, and everything in green is what's missing on our table of values. So, for example, to go from negative 5, 0 to negative 4, 3, you'll see that there's the down 3, right 1. Do you see that? That's the negative 3. And the next one will be negative 1, so this part's missing. So if I had to make a table of values, we have negative 5, 0, negative 4, negative 3. I suppose that negative 3, my value is going to be 2, 4, negative 4, negative 2, which we don't have on here, that's in green there, negative 2, negative 3, negative 1 we're missing, which is I'm going to suppose 0, and then we go back onto the graph 0, 5, then 1, 2, and then 2, 21. And then we already saw that this was here a plus 3. Here this is that's a minus 3. Minus 1. Then this would be a plus 1, plus 3, plus 5. That should be 12. Plus 7, plus 9. And then the answer is quadratic, because then you can do a second common difference there. Plus 2, plus 2, plus 2, plus 2. From here to here is plus 2, and then plus 2. So that answer is going to be quadratic. A little bit tricky, but yeah, you'll recognize that if you graph it, or you can see that pattern there. Here was plus 9, then plus 7, and then you can just work your way backwards. Question number 8. Brooklyn had a rumor. She tells the rumor to 2 people the next day. So here's Brooklyn. And then she tells it to 2 more people. The 2 people then, she told each of these people tell 2 more, who then go and tell 2 more people the following day. So this is day 0, 1 people know the secret. Day 1, a total of 2 new people, so let's write new. And then day 2, 4 people, 4 new people. And so what's happening is you're recognizing that you're multiplying by 2 here, right? If these people go and tell, this person goes and tells 2 more people, and this person goes and tells 2 more people, and this person goes and tells 2 more people, right there is now 8, which is a multiplying by 2. When you're multiplying there with a common ratio, that would be exponential. Oops, recorded this out of order, so here we're going to use the question number 7. And in question number 7, let's see if I can get in there. There it is. If you look at this graph, although this part looks like a linear, and this piece looks like a linear, the answer is an absolute value. So it's not, the common mistake is linear. It's not quadratic. It's not a U. It's not quickly going up or quickly down, and not curved. So the answer is neither on that problem. Again, the common mistake is to think it's linear, but it's an absolute value function. So the answer is end.
Alright, question number 9 asks how many white tiles will be in design 5 of the pattern. So if you look at design 1, I have a total of 5 tiles there. And 2, I have 1, 2, 3, 4, 5, 6, 7, 8. And third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you recognize what's happening is you're adding 3 here. And until I get to the 5th pattern, the answer would be 17 tiles. Now the question is how many tiles? It doesn't say draw out the tiles, so you're not going to make me count. And to get the 0 pattern means you would have actually 2 white tiles. And if you needed to write an equation, that would be y equals 3x plus 2, because 2 is your y-intercept, 0, 2, and then 3 is your first common difference. Explain your reasoning. Arithmetic, first common difference is plus 3. So I give you a plus 1 if you said I drew it out, or if you just said the word adds, I give you 1 point. Let's look at some student work. Student got 2 points for 9A, 9B, they just had the word add, so I go and give them 1 point. There's 17 white tiles, and then in the student's explanation, they have the differences in each design is increasing by 3 white tiles.
Let's go over question number 10. Number 10 says the school swim team holds a car wash to earn money for an upcoming trip. The table lists the number of hours that car wash runs and the amount of money earned during the car wash. Complete the table. So I told you guys in class to switch the numbers from to 20, 22, and 24, and then you recognize that your common difference there is a positive 2. That number is a 3. So if you graph this, the number you're missing there then is, if you go backwards, is just minus 2, so it'd be 18. Now, a lot of students thought 0. Nothing at the car wash and the amount of money earned would be 0, but maybe someone makes a donation to your club and they didn't even get their car washed, and that's why you didn't wash any cars and you have 18 as your starting point. So 2 points to have that complete, 1 point if you made a mistake. Common mistake was putting 0, 0. Again, I just explained why it's not in 0, 0. Someone might have donated money. And then you have a linear equation there. So 2 points that you connect the dots and it's a straight line. 1 point if it's not a line. Again, common mistake was 0, 0. To write an expression, because your common difference here is first common difference that's linear, so I'm going to use y equals mx plus b. If you just wrote down y equals mx plus b, I only give you 1 point. You're supposed to write the expression or equation. Your slope is 2, and then your y-intercept is 18, 0, 18. I gave you 1 point if you wrote 18x plus 2. That's wrong because you're not getting $18 per car, and you're not starting with $2. So that question number 10 was at 6 points.
Here's the extra credit question. Name one of my children. The answers are Brooklyn, Hezekiah, Hadley, or Eloise. You only have to name one of those to get the 2 points. Kudos to that one student who got all of them. Alright, on the backside, question number 11 says analyze the table and be able to, 11A, complete the table of values. So here you have a table of values. You should have recognized here you're doing plus 4, then you're doing plus 6, and then you're doing plus 8. So this would have to be plus 10, so that'd be 30, and then add 12, which would give you 42. And also you have counting here by ones. So that's all you had to do to get full credit. You recognize that this is not the first common difference, so it's not linear. And if you do it again, plus 2s, plus 2s, plus 2s, then you have a second common difference. Second common difference is quadratics. We talked about in class. It says write an expression that represents the pattern. So we have the y-intercept here, 0, 2. So to get this problem correct, extra credit. You have standard form here. Your c value there is 2. Your a value is your common difference divided by 2, which is 1. And then basically here you solve for b, and you use any order pair. And I used the first one, 1, 6. So x value is 1, y value is 6. Put 1 for x. Y is 6. 1 squared is 1. 1 times 1 is 1. B times 1 is just b, and then you have the 2, so 1 plus 2 is 3, and then subtract 3 from both sides, you get b equals 3. So you have an a value that's 1, b value is 3, and a c value, which you already had there, was 2. So your equation to get extra credit is y equals x squared plus 3x plus 2. This extra credit question, the student clearly recognizes there's a second common difference, but when they try to write this extra credit question, they wrote a linear incorrect. Question number 12. Your Hyatt Home Improvement uses H-shaped tile designs on their buildings, advertisements, and vehicles. The designs they use follow a specific pattern. The first 3 designs are shown. Design 1, 2, 3. Draw design 5. So you didn't get any credit for drawing design 4. I was looking for 5. So something you should recognize, you take this design number, and if you square it, Excuse me. This one here is a 2 by 2. So you're just taking that number and squaring it, not what goes in the inside. Take 3 squared, that is 9. So 5 would be 5 squared. 5 by 5, that gives you 25. So what's happening here? Complete the table. So total number of squares. So here in the first design we have 7. Second one is 12, and the third one you have 19. So you should recognize you're going by, here you're adding 5, and then you're adding 7, 19, and then 11. So you have a second common difference, which is a positive 2. Quadratic, because it has a second common difference of +2. Write an expression to represent the total number of squares in design n. So same thing as above, your common difference becomes your a value. So common difference divided by 2, so your common difference was 2. 2 divided by 2 is 1. And then you put in your c value, which you go backwards. So this is 5, then that'll be 3. So 4 plus 3 gives me 7. So 0, 4 is my c value. And then you pick any order pair. I picked the first one, 1, 7. So your x value is 1s. And your y value is 7. So then you just simplify. 1 squared is 1. This becomes just b. And then 4, so 1 plus 4 is 5. Subtract 5, and your b value becomes 2. So a value is 1, b value is 2, and then your c value is 4. Your expression is y equals x squared plus 2x plus 4. Let me show you a second way how to get x squared plus 2x plus 4, or if you use something like n squared plus 2n plus 4. This is how I saw it. The x squared is represented by the design number in a square. So if it has 2, it's 2 by 2. And then I have 2 x's. So here's your x, the length of 1, and then this side length represents the design number x. And you have 2 of those. 1, 2. And then this plus 4 is just the 4 on the outside. It's 1, 2, 3, 4. So that's the second way that I got this expression. Here's a third way. If you take our number and you square it, and you add that to 2 times the design number plus 4, you'll recognize that I did that for each of these. What's happening, right? 3, square it, you multiply it by 2, and you add it to 4, and you keep doing that. And you can either put an x value or an n value for your design numbers, and you'll get the same quadratic expression for D. Let's look at E. E here tells us to how many squares are in design 8. So you could draw that out, but I don't really want to. And I'm just going to use this expression from above. So that would become 8 squared, which is 64. 2 times 8, which is 16, plus 4. So this becomes 20, plus 64 becomes 84. 84 squares in design 8. Okay. You got 0 points for the correct answer. We've talked about in the beginning of the year. If you just have a correct answer and no work, I'm going to write SW, which means show work. 12F, use an algebraic expression to determine the total number of squares in design 51. So here I want you to use your expression above. So if you put in 51 there, that's 51 squared, which means 51 times 51, which is 2601. 2 times 51, which is 102, and don't forget the 4. Add those together, you'll get 2707 to be able to get full credit. Let's look at some student work. All right, so this student did a 5 by 5. That was good. Filled out. I gave him full credit, so if that was wrong, that's okay. I still gave you full credit. Interesting enough, the student didn't recognize what type of function family we have here, so exponential is wrong. Didn't get a point for explaining. Somehow they knew it was quadratic. At least they're trying something. They have 84 with some work. I gave you full credit for that one, and then the correct answer with full credit. I wanted to show you this person's equation, and actually is correct. N squared plus 2n plus 2. So the n squared is the design number, so this is 3, so this is represents the n squared, which is just really n times n. And then there are 2n plus 2, so this represents n plus 1 plus 2, and you have 2 of these that would be correct. Here's an example with correct answer, but I would have given this one 0 points. I was going to say for this drawing, you just need to take your time. This one got, I know I would score 1 point because it has 4 boxes. This one goes 5 across, and it should be 5 to 5, not 4 there. Question number 13, determine whether the two expressions are equivalent. Explain your reasoning. So on the left side here, I have a 1y. If you put a 1 there, and a 1, and a 1, and a 3. So 1 plus 1 plus 1 plus 3. I combine like terms there, I get 6y plus 2. And that is equal to this side, which has 6y plus 2. So yes, they are, the expressions are equivalent because you are combining like terms. Let's look at some student work. Here's an incorrect response. You can take a look at that one. This one, I see they added combined like terms inside, and then these two, they have 6y plus 2 and show they're equivalent. I'm happy with that.
Question number 14, the Ken. Fill in the blank squares so that each row and each column contain all the digits 1 to 4. Numbers and cages and repeat as long as they are not in the same row or column. So again, it has numbers 1 to 4. I like to write the numbers 1, 2, 3, and 4. If you ever see these on your quiz like this one, the reason why I write it out twice is you do it once on your quiz, and then this is your correction. So you'll see the cages, they're a little bit darker. And use a pencil. I'm going to look for all the freebies. So those are the ones that don't have any numbers here, or math operation, sorry. So this is a 1, and here's a 4. Sometimes it's okay to guess. For these with the corners, a lot of times these are repeating numbers. So 2 numbers that add up, 3 numbers that add up to 11. If I choose, say, something like 3 and 3, that give me 6, and that would have to be a 5, but that doesn't work, so I'm going to guess 4. I guess it could be 3 different numbers in this case, but I'm gonna guess it's a 3 and a 4 and a 4. So 3 plus 4 is 7. 7 plus 4 is 11. Now, if you recognize that how many 4s I have, there's a 4 here in this row, 4, 4. I'm missing a 4, and there's only one missing here. These 2 multiply to be 4, so that has to be a 1. Let's see other 2 numbers. This row here is missing a 2 and a 3. I could put a 2 here. Let's just try it. 2 and a 3. So these 2 numbers add up to 5, so that would be 2 plus 3 equals 5. And this one can be a 1. 1 plus 2 is 3. Here I'm missing a 3. And here I'm missing 2 numbers, but this one says 2 numbers that subtract to be 1, so this has to be a 2. So this is not a negative 1. This column here is missing the number 1. This row here is missing the number 2, so 2 plus 1 is 3. We're missing a 3 here. So 3 plus 2 plus 1 is 6. And you can double check, there's no repeating numbers in a column or in a row. So that's how you do a Ken.
I love math. You don't love math? What's wrong with you?